Hey everyone! In this video we're gonna have a look at how to create a character prop digital asset in Houdini. It will be a simple asset that the character can pick and hold and move around. So we will look at how to create constraints and space switching inside the asset. We will also create a few animation deformation controls that the animator can use, and in the end see how everything fits together. So let's have a look. So before we dive into controls and start setting up deformers, let's first see what we got here. So this ray gun asset is going to be held by a character. So one thing we'll need to do is create a constraint setup that will allow space switching. So the control will have its own control for moving around, but also be able to switch the space and be controlled by a character's hand, for instance. We'll need to set up some small animated deformers for this trigger here, maybe this button. This front part could be would be nice if it could be animated by a band deformer. And since it's such a cartoony design, we might want to go for the squash and stretch and to prevent to be completely rigid. So for the main control, we're going to use just one null and one null for the constraints. So, and this null is going to be placed at the origin. As you can see, also the geometry has been placed this way, so that the center should be the origin. So say bring control and create another one called constraints. We're going to change the shape, something like a box. Okay. And we're going to hide the constraints because this is not needed by the animator. And now we can add some parameters to our control. And the parameters we're gonna need is, let's see, so we're gonna use trigger, then we're gonna use side button, and all this should be auto-scoped. We're gonna use the, so we say the band front, and this one should be -1 to 1, because this band front will probably just want to go up and down. It's just so we can get some jiggle on it. And we say squash and stretch. The same -1 to 1. And then we're gonna add another parameter, and this one is gonna be the integer, and let's just say custom space, and this is 0 to 1 autoscope, say custom space, and another one, the operator path, which you can say custom space object, and this is gonna be, for instance, this is gonna be a character's hand in case when the character is holding this this asset. when the character will pick up this ray gun, we're going to set the custom space value to 1, and custom space object will be set to character's hand, for instance. If custom space is going to be 0, it's going to be animated in local space of this ray gun control. Okay, so now if you control, we have trigger, side button, bend front, quotient stretch, custom space, and custom space object. So now that we set up the parameters that is going to control the ray gun, we'll go into geometry and connect parameters and to the deformers that we're going to create. But first we're going to create some groups for each individual deformer. So first we're going to set trigger group is going to be points, trigger, and the base group is going to be this trigger. And then I say the side button group, it's gonna be just this button. And for the bands, for the band front, we'll set it. We'll select for now these points here, and then we'll see if we need to correct anything. So for now, this is fine. So now let's just name also these groups correctly. So this is side button, and this is band front. So here is our base setup. So we're going to say groups, and now let's first set up the trigger, and for that we're going to use transform sub. I say points, I say trigger. Now all we want is to move this trigger back. So what we need to do is move the pivot point to correct position like this, and check if this is fine. Maybe just a little bit up. Yeah, that's gonna be fine. So this is gonna be our trigger deform. Now all we have to do is connect this trigger to our, let's see, rotate X, and how much. So here you see, so at 43 degrees we want to have the value of 1. So you say 43 times trigger value of the control, we're going to have a nice 0 to 1 value. So we're going to do the same for the side button. So transform, and say side button deform, points, and side button. So move the pivot point into the center. And we're going to do a similar connection to the control. Side button, copy parameter. So here should be sort of a value of 1. And in this case it's translate X. So here you have a button control. Now for the band front, we're going to use band deformer. the group is band front, and let's see. So the direction we're using is okay, but the capture length is too long, so I just lower the capture length. So this is sort of fine, but we're gonna change the capture origin in the z-axis and just put it somewhere right here, so that we get a nice deformation throughout the front part. Maybe just something like this. Okay, that should be fine. Again, go to our control, copy the band front parameter, and let's say that one is at 90, so 90 times band front parameter from the control. Now for the squash and stretch, let's first see what another band gives us. And let's disable the band. And see what the length scale does. We're going to change the capture origin and put it to the back, so here, and so we could use something like this. This is just to give it a bit of scaling and squashing during some extreme motion. So for us and for this tutorial, this will be fine. Again, let's copy squash and stretch parameter, and in this case paste relative reference +1. +1 because by default it is the length scale should be 1, and we want the default as a parameter to be 0. So we have something like this. Let's just change the capture length. So this is for squash and stretch. To finish our deform setup, we can just another null. Let's call it out. And one thing we should look here is our deformation order. So if we see here, change the trigger, change side button, band front, and squash and stretch, we see that they work as expected. But if we change the deformation order, let's say that this band squash and stretch would be the first to deform, something like this, or rather yet, let's just copy this one here and put this one on top, and let's compare. So let's create a switch node like this. We see that the formation is different. So this is because, especially with let's put this band front, something like this, so it's more obvious. So as you can see, the formation order plays a huge role in these things. So we take first the local deformers that only influence certain parts. So the trigger, side button, and band front. And this band squash stretch affects everything. So all the deformation that we have here is then fed into the band squash and stretch. But if we do it the first and we create first this squash and stretch, let's do something like this, and we do first squash and stretch, this trigger pivot point is at the wrong position. Actually, it would have to be here, and this side button is okay because it's only one axis, but this one is completely doesn't affect anything anymore because the band is happening at the wrong position. So it's really important that these things are done in correct order. So that the squash stretch that affects everything is done, for instance in this case, at the end, so the formation is correct. So let's see again. So this is wrong and this is correct. Okay, so now for let's just reset all these parameters. Now for the custom space, we're gonna use fetch node. Fetch. So what fetch does is that it copies the transformation from this fetch object. So fetch custom object, and we want to use the parent transform of the fetch object, and I'm going to say custom space object, copy this parameter and paste relative reference, and when we create an asset, we're going to promote this parameter to the digital asset. So you'll just create another null and parent it under this fetch object and just say custom object class. So we can hide this. Now all we need to do here is create a blend constraint. So blend, disable scale, we will not scale constrain it, keep position off because the Raygun constraint is at the origin and this custom object pass is also at the origin. So we select the Raygun constraints null and the custom object pass null. So now if we go into Raygun constraints, we see that the constraint networks has been created. All we need to do now is actually just copy the custom space parameter and go into constraints and say paste relative reference. So if now we move this custom object, let's say here, something like this, and we say custom object 1, we see that this null is affecting our Raygun. So let's set back to 0 and reset the transform of the custom object pass. So now we can start creating our digital asset. We select all the controls known as geometry, materials, and this custom fetch custom object. We edit, collapse selected into subnetwork, and name this Raygun rig. And now we're gonna just create a digital asset, say Raygun rig version 1. And just save into this default library. For now, I just leave it like this. So let's see that our ray gun control basically has all the necessary parameters that we need on our asset. So if we go into our type properties, parameters, we can hide this subnet, and we can also hide this transform, because we're going to promote our own transformation controls from the ray gun control. And I'm going to say controls, transform, and what we want to promote here is translate and rotate and scale. Just name these controls, make it easier. We're going to create a separator and also promote controls that we created. So for translate, let's just rename, let's say raygun T and raygun R and raygun S for the scale. So let's see what have we here now. We have our transformation controls. What we also nice, maybe we should just also promote a rotation order for the control, because we don't know for every scenario what rotation order will be best. So we're just gonna go for rotation order and export parameter to type properties. So rotation order. We leave this auto scope off because we don't want to key this channel. Okay, so let's go back, see what we have. So we have our mic control, scale is nice, trigger, side button, bend front, squash and stretch, and custom space, which we will set up in a minute. Now for the custom space, let us create a null and call it custom target, and let's move it somewhere like here and here, and just drag it into custom object space. So when we say set custom space to 1, it will switch into this custom target space. So say 1, now this target controls the transformation of our ray gun. Now this ray gun control can still move under this new control. But what if we want to switch space but also keep the position of the default space? So to do that, we're going to type properties. We're going to create a button that will say switch space. This will be switch space button. And this button is going to call a function inside our HTML module, and this function that we will create is going to be called switch space. It's going to be a Python script, and all this script does is goes into our module and basically calls the switch space function. And this function we will create under scripts. I'm going to say Python module and say switch space parameters, and so if we go into parameters and go switch space, for now it doesn't do anything, but we will change it right now. First, we need to know our node, and so we need to first retrieve our HDA, and then our node is our control. So first, and then we have to check what is the current space value. Farm custom space. And after we have space, we can get the old transformation. Transform old. Because we store this old transformation. So when we change space, we will match back to this old position. Now we can change the space parameter, or the custom space parameter, and say custom space set to 1 minus space, so we reverse it, and calculate the new transformation. Now the problem is we cannot set this transform node on our ray gun control null directly, because they're connected to the HDA model. So we need to calculate this new transformation and apply it to the HDA ray gun transformation parameters that are controlling ray gun control transformations. Transform is transform old. This node parent. Here we are calculating the new transformation matrix. We won't go into matrix transformations into detail here, but basically we are just calculating the new matrix, which will allow us to extract the transform and rotate values that we'll need later. One thing we should do is also get into account our rotation order. So I'll just do h bar rotation order. Right now. And we should also do a rotation order in text value. We're going to need these values. Basically x, y, z will be value of 0, and x, z, and y will be value of 1. So we'll just write this down. In y and do y. Nope, edit mistake, y, z, x. Okay. So So now explode matrix. We need to explode our transformation matrix, and this is done by using transform explode and using rotate order is our rotate order text from index rotate order, and this gives us the actual transformation rotation values that we can apply to our ray gun and ray gun translate and ray gun rotate. So if you do phd ray gun t and set and do explode translate and do the same for rotation, ray gun r set explode rotate. Let's see what we get. So accept and see. What's that? Oh, functional has no attribute inverted. So let's see where is the mistake. Oh, here not pre-transform. This is a function actually. So let's see now. Globe name explode is not defined, and there's okay. Let's see this. Explode matrix transform explode matrix. Let's see now. Power multiplier. Okay, this should work now. Let's go to custom object, or better yet. So let's say we move the ray gun here, and we just want to switch to this object, the custom space, and move it around. Okay, this works nice. And if we change the rotation order, and we see, we'll check if it still works. It works. Okay. So if we do it like this without the switch space, we see it jumps. Okay. Now all we have to do is a simple scene cleanup. Set everything to 0. We can delete this custom target, save node type, and match current definition. And we have our asset ready to animate. Thank you for watching. I hope you found this video about rigging a character prop asset useful, and hope to see you next time. Bye bye.